In this video, we're going to go over questions that involve diluting solutions. So diluting, exactly what it sounds like. You take a concentrated solution and you add water to it, or you add a solvent to it, which most of the time is water, to make it less concentrated. So it's important to know that the concentration and volume will change when you dilute a solution. However, the moles of your solute will remain the same. The best analogy I've seen to just kind of make this point is if you imagine that you had a glass of water with a couple of loonies in it. And in this scenario, we're just pretending that the loonies represent our solute. Okay? And let's say we create an initial kind of quote-unquote solution by having these loonies and pouring in 200 milliliters of water into the glass. Okay? So this is our solution. We have 2 loonies per 200 milliliters of water. Now, saying that each of these loonies represents a mole, right? Then if we have 2 moles of loonies in 200 milliliters of water, that would give us a concentration of 0.01 moles per liter of our loony solution. Okay, but let's say we added in 400 milliliters of water. So now we have 2 loonies in 600 milliliters of water because we took our initial 200 milliliters and we added 400 milliliters. So now we have a total of 600 milliliters of our solution. So then the point of this is that we still have 2 moles of loonies in the solution, okay? But the volume and the concentration will change because if we go 2 divided by 600, now we have 0.00333 repeating, okay? So mole per liter. So that's just an analogy that you can kind of think of to make the point of when you dilute a solution, concentration and volume will change, but the moles are going to remain the same. So here's another example just illustrating that point. It's a little bit more visual than my loony analogy here. So we have 1 liter solution that has a concentration of 1 mole per liter, and it has 1 mole in it. And let's say that we add in 1 liter of water. So then for our final solution, since we added in 1 liter of water, we now have 2 liters. Okay, but we still have the same amount of moles. Okay, so figuring out concentration, right? Concentration is moles divided by volume. So 1 mole divided by 2 liters. Oh, that's supposed to look like an L, not a 2. So that's going to give us 0.50 mole per liter. So as you can see, moles stayed the same, however, volume and concentration change. And the more you dilute a solution, the lower its concentration is going to be. So let's just take a moment to highlight this part here. Okay, so the formula that we use to calculate new concentrations of diluted solutions, or figuring out whether we want to figure out like the original concentration or the original volume of what we used for the original solution. The formula we're going to be using is C1V1 is equal to C2V2. Now the trick with this formula is you can use any units for volume and concentration in this formula because they will cancel out. The key is that like concentration 1 and 2 have to have the exact same units. Volume 1 and 2 have to have the exact same units. Okay, so most of the time the variation is going to happen mostly with the volumes. So your volumes typically are either going to be in milliliters or liters. And so applying that to this formula, your volume 1 and 2 both have to be in milliliters if you're going with milliliters. Or your volume 1 and 2 have to be in liters if you're going to be using liters for your units. Okay, but you can't have volume 1 be in milliliters and volume 2 be in liters. Okay, because the units aren't going to cancel out. Okay. Another thing that I find helpful for students is just imagining that like the C1V1, that is like your original or your initial solution that you're starting off with. Original. Whereas C2V2, you can think of that as your final solution. So I'm abbreviating solution just to SOLN. So just to remember, like this last part is saying quantity of solute doesn't change. That's another way to say your moles of your solute is not going to change. Okay, which we talked about up here. All right, so example 1. What is the concentration of the solution if 25 milliliters of 2 moles per liter of sodium chloride solution is diluted to a new volume of 125 milliliters? Okay, so one thing I want to draw your attention to, if you see the word of between two values, typically that's going to mean that these two values belong to the same solution. Okay, and since we're saying if we take 25 milliliters of a 2 mole per liter solution of sodium chloride and we're diluting this, it makes sense that this should be our initial solution. Okay, and we're diluting it so that it creates a new solution that has a volume of 125 milliliters, and we're asked the concentration of what that new solution is. So if we're writing out our list of givens, then I'm going to go 25 milliliters of a 2 mole per liter solution. The new concentration or the final concentration, we have no clue, but the volume we said was 125 milliliters. Okay, so let's write out our formula. C1V1 is equal to C2V2. And now I'm just going to isolate for C2 because that's what we don't know. So V2 is multiplying C2, so I'm going to do the opposite, which is divide. What I do to one side, I have to do to the other. So then C1V1 divided by V2 is going to be equal to C2. Okay, so that's how we're going to find our new concentration. And what I'm going to do is I'm just going to flip this equation around just so that my unknown is on the left-hand side. And let's plug in our numbers. So C1, that's that 2 moles per liter. V1 is 25 mils. And then we have V2, which is 125 milliliters. So this is why the note in the previous page said you can have any units for concentration and volume just so long as the initial units match up with the final units, because with this calculation here we can see, okay, milliliters is in the top and the bottom, so they cancel out, and we're going to be left with moles per liter for our final units. So C2 is equal to, so once we take 2 times by 25 and then divide it by 125, that's going to give us 0.4 moles per liter. Now, looking at my given numbers, all of the numbers given to me in the question are in 3 significant digits. So we got to change this so it has 3 sig digs, but keep the same value. And how we're going to do that is just by adding zeros after the 4. Okay, so now this has 1, 2, 3 sig digs. Remember, leading zeros do not count as significant digits. So moles per liter. Example number 2 says if we have 1.5 liter of a 0.4 mole per liter solution, so of means that these are connected, and is diluted, so that means that this should be our initial one, so our starting solution, and then we dilute it. Okay, by adding, okay, so that's a key word. It's a key difference from the previous example, because the previous example told us what our final volume was going to be. But this is saying, okay, we're adding 300 milliliters. So that is not telling us what our final volume is. It just means that we're adding in 300 to the beaker. What is the new concentration? Okay, so list of givens. So initial concentration, 0.4. Initial volume, 1.5 liters. C2, we have no clue. V2. All right, so how we're going to figure out our second volume is we're going to take our initial volume and we're going to add 300 milliliters. Okay, but the problem being is that liters and milliliters are 2 different units. So we either need to convert liters to milliliters or milliliters to liters. Arbitrarily, I'm just going to choose to convert milliliters into liters, and I'm going to do that by dividing 300 milliliters by 1,000, which is going to give us 0.3 liters, and I'm going to add it to the 0.5 liters, so that's going to give me 1.8 liters. Okay, so if you're wondering how do you know to do this, you're going to look for the keywords by adding. That will tell you that in order to figure out your final volume, you have to add the initial volume to however much water you're adding. All right, let's go C1V1 is equal to C2V2. All right, so we're looking for C2. I'm just going to jump straight to here because I've already showed you how to get this formula. And now I'm just going to plug in my numbers. Another reason why I wanted to do liters was to show you that units, doesn't matter what units you have, just so long as your initial and final units for either concentration or volume are the same. Okay, so liters cancels out. And I'm going to have to move this up. Okay, so if we take 0.4 times by 1.5 and then divide that by 1.8, we're going to get 0.3 repeating. So the line over top just means the 3's just keep on repeating. That's moles per liter. So then, looking at my numbers given to me in my question, it looks like the least amount of sig digs, or the number with the least amount of sig digs, is 1.5. So that's 2 significant digits. So my answer has to be in 2 significant digits. So 1, 2. There's my cutoff line. C2 is equal to 0.33 moles per liter. Okay, last example for this section. How much distilled water must be added to 45 milliliters of 13.6 mole per liter ammonium chloride solution to get a final concentration of 0.6 mole per liter solution? Okay, so 45 mils and then of means these are connected. Okay, so if we're adding water to this solution, this should be our initial solution. Okay, now the tricky part here is it's asking us, okay, how much water did we add? Okay, so that's your key words that you're going to look for to tell you that you're going to do something a little different than the first 2 questions that we just did. Okay, so I'm just going to start off with my list of givens, and then I'll show you how this question's going to differ. So our initial concentration was 13.6 mole per liter, 45 mils, and volume we have no clue, 1.6 mole per liter. Okay, so what we're going to do is we're going to figure out our final volume. But keep in mind, final volume does not tell you how much you added. It just tells you the total final amount of solution that you have. Okay, that's the difference here. So C1V1 is equal to C2V2. We are looking for V2. So C2 is multiplying V2, so I'm going to divide. Those cancel out. So V2 is equal to C1V1 divided by C2. Let's plug in our numbers here. 13.6 mole per liter. And we have 45 milliliters. And we have 1.6 mole per liter. Okay, so moles per liters, they cancel out. So our units are going to be milliliters. So 13.6 times by 45, then divided by 1.6. That's going to give us 382.5 milliliters. Okay, so reminder here, what this represents is the final total volume. It does not tell you how much water you added. But it can help you figure out how much water you added. Okay? So at this point, what we're going to do is we're going to figure out, okay, we started off with 45 milliliters and we ended up with 382.5 milliliters. So we need to figure out the difference between our final and our initial. Okay, so water added is equal to final volume minus initial volume. Okay, so final volume 382.5 minus 45, and both of these are in milliliters. I'll have to squeak that in. So if we subtract those two, we are going to get 337.5 milliliters. So looking at our significant digits. It looks like all of the given numbers are in 3 sig digs. So our cutoff line is going to be right here. So 3 sig digs, so 338 milliliters of water. Okay, and because this isn't part of a chemical reaction equation, I'm not going to worry about the state. Okay, you should be able to assume that it's liquid water. All right, let's move on past these practice questions to the next part here. Okay, so the reason why we want to get good at figuring out like how much water do we need to add in order to create a dilute solution is because these are skills that you'd need to have in order to do a dilution lab. Okay, so in this question here, let's zoom out a little bit here. So it says it's the preparation of a solution by the dilution of a solution of a higher concentration. Okay, so you are asked to prepare 100 milliliters of a 0.02 mole per liter solution of, let's correct that, copper 2 sulfate. So I'm just adjusting the superscript, or sorry, the subscript, from a solution of 0.2 mole per liter solution of copper 2 sulfate. So the materials, if we were in a lab, that we would need would be a wash bottle, dropper, pipette, pipette bulb, funnel, and volumetric flask. Okay, so let's start off with figuring out the volume of the concentration solution that we would need in order to create this new solution. So let's write out our list of givens. So we have 100 mils of a 0.02 mole per liter solution we want to create. So that's going to be V2 and C2. So 100 milliliters and then 0.02 mole per liter. And then V1 C1. So we're told that we're starting off with a 0.2 mole per liter solution of copper 2 sulfate. So I'm going to throw that in there. Actually, there's a couple zeros there. And we have no clue what the volume is that we need. Okay, so another way for dilution questions that you can check that you have the concentrations in the right spot. For dilution questions, C1 is always going to be a bigger number than C2 for dilution questions only, okay? Or that's the only type of question that I can guarantee in which C1 is going to be bigger than C2. All right, so let's figure out how much we would need of our initial solution. So C1V1 is equal to C2V2. We are isolating for V1. Got to divide by C1. And the reason why we're dividing by C1 is because C1 is initially multiplying V1. So we got to do the opposite, which is divide, and then that cancels out. So we have V1 is equal to C2V2 divided by C1. And now we just plug in our numbers here. So 0.02 mole per liter, 100 milliliters divided by 0.2 mole per liter. So the units cancel out, so we're left with milliliters. All right, so 0.02 times by 100 divided by 0.2, that's going to give us, that's V1, is going to be 10.0 milliliters. So we need 10 milliliters of our initial solution, and in the lab, typically your initial solution is called your stock solution. Okay, so how you would create this dilute solution is, first what you do is you would take the pipette bulb and the pipette, okay, and essentially you would have your stock solution in a beaker. You would take your pipette and take out 10 milliliters of that stock solution out of the beaker, and you would put it in your volumetric flask, and then you would add in water to your volumetric flask until you got to the top of it. You'd have to use a funnel to get your water in. Okay, and then once you get close to the line here, you just go drop by drop with the dropper there until you get the bottom of the meniscus to the line that's there. So it'd kind of look like, oops, that's a little bit high. Kind of look like this. Okay, and once you have the bottom of your meniscus to this line, you'd put a stopper in this, and then you would invert the volumetric flask about 10 times. Okay, just to make sure that you have the same concentration throughout the solution in the volumetric flask. All right, so don't worry about example number 1. You're not going to have questions involving density given to you. But let's take a look at question number 2. Describe how you would prepare a 100 milliliter solution of a 22% acetic acid by volume. All right, so since our solution, the units for it is milliliters and it's by volume, this is going to be a percent volume by volume situation here. Okay, so let's go volume of solution is equal to 100 milliliters, and then percent volume by volume, that was 22%, and volume of solute, we have no clue. Okay, that's what we got to figure out. So as a reminder, the percent volume by volume formula is volume of your solute divided by volume of your solution times by 100. Okay, now as a reminder, your solute and solution, they just have to be in the same units, and since my solution is in milliliters, I'm going to put both of them in milliliters. All right. So we're looking for the volume of the solute. Now, because this involves percentage, these types of formulas, I like plugging in the numbers first and then rearranging. So that's what I'm going to do. So 22%, I'm going to keep volume of the solute just as a V, and then 100 for the solution times by 100%. Okay. So what I'm going to do is I'm going to isolate this fraction. So the 100% is multiplying. I'm going to do the opposite, which is divide. Okay, so then this would cancel out. So what we have is 0.22 is equal to volume of our solute divided by 100 milliliters. Since 100 is doing the dividing, I'm going to multiply by 100. So then we have 22 milliliters is equal to our volume of our solute, which, how many sig digs do we have? looks like we've got our answers already into SIGDIG, so we're good on that front. So if I was to describe how I would prepare this solution here, essentially what I'd do is I'd take a little bit more than 22 milliliters of acetic acid, because that's our solute, and I'd put it into a beaker. Okay, and then what I'd do is I would pipette out 22 milliliters and put it into a volumetric flask, and then dilute or add in water to the volumetric flask until I had the bottom of the meniscus on the line on the neck of the volumetric flask. I would stopper it and then invert that volumetric flask 10 times. That's how I would prepare this solution. Okay, so I'm just gonna go ahead and rate that out. By the way, the volumetric flask would have to be a 100 milliliter volumetric flask. So maybe about 25 milliliters of acetic acid. And then pipette 22 milliliters into a 100 milliliter volumetric flask. Then add water to the fill line. Stopper the flask to the fill line on the volumetric flask. Stopper the flask and invert 10 times.